Hello again, everybody. So we're continuing our work through quadratics here. What we did before in the previous videos to this one is we talked about graphing in vertex and intercept form. We talked about graphing in standard form. So for all these different forms, what we want to be able to do is transition between them. So we want to transform them, change them. Quadratics in disguise. Anyway, transformers reference. Anyway. So our essential question today is, how do we switch between different quadratic forms? Because we don't want to just stay in one ever. It's like sometimes we might want to see a different one or see what another one looks like. So we want to remember from previous lessons, vertex form looks like this, where there's a squared, a quantity squared in there in your A, H, and K. Intercept form looks like this. Intercept form has two different x minus or plus numbers. And then standard form is where you have x squared plus x plus c and then a number and some numbers in there. So it's a little bit different than vertex and intercept form. So mainly what we're going to be doing today is going from intercept form to standard form or vertex form to standard form. We go to standard form because it's standard form. That's the form that most of the time we want our quadratics to look like. So our first thing is our answer to our essential question, which was how do we switch between forms. The answer is FOIL. If you remember from 9th grade, FOIL is first, outer, inner, last. So that means we multiply the first two numbers, we multiply the outer numbers, the inner numbers, and then the last number. So I color coded them with this for this problem. So example 1 says change from intercept form to standard form. So what we want to do is we want to use FOIL. We want to multiply our first terms first. So x times x gives us x squared. That's marked with the black there. And this color coding carries through all of the problems. The next one is outer. F-O. O is outer. Would be x times negative 8. That'd be our outer two numbers of the 4. And that is right there. The inner is next. 5 and x gives us the green 5x there. And then the blue 5 times negative 8 is negative 40. You do keep the negative with the 8. Just like you keep the positive with the 5, because that 8 is a negative 8. Then we can combine like terms. I mark that by squiggling below the x's there. We add those together and then we get our final answer of x squared minus 3x minus 40. I know it's in standard form because I have an x squared, an x, and a number. And that's how it looks. Well, pretty, not too tough here. So here's our next one. We got a couple more intercept form problems to do. So again, this one is a little bit different because it has a number in front, but the first part of the problem is exactly the same. From here down to the blue is exactly the same as the problem we just did. You do first, that's the black line, x times x. You do outer, x times 3, that's the red. You do the inner, negative 1 times x, that's the green. And then you do the last, negative 1 times 3, or negative 3. So again, you're just foiling through. I underlined with the blue line. We can combine like terms there. Now the last step that's different here is because there's a 4 in front, we don't touch the 4 until the very end. We don't do anything with the 4 until right here. And judging by these red lines, you want to distribute that 4. So 4 times 4x squared. 4 times x squared is 4x squared. 4 times 2x is 8x. 4 times negative 3 is negative 12. So again, the 4 doesn't matter up until this very last step when we multiply everything by it. Otherwise, the rest of it is exactly the same as when we do before. Same with this one. We're still going from intercept form to standard form. So again, this negative 7 doesn't matter until the very end. Again, we do first x times x, x squared. Outer, x times 1 is 1x. Inner, negative 6 times x is negative 6x. And last, negative 6 times 1 is negative 6. And then the very last, so that gives us the blue. We combine like terms with the blue. And then the last thing we get is we distribute that negative 7 to get our answer there. So that is intercept form to standard form. And vertex form to standard form is pretty much the same thing. The only difference is that vertex form has an x squared, or has a squared on the quantity. So what that squared means is that means it's 2 of that thing. So what I did in the red here means 2 of same thing. I rewrote this black equation in red, so it said x minus 1 and x minus 1 twice. Then you FOIL that. So I did that in the blue. It says FOIL. I combine like terms already. I kind of skipped a step in there. So you FOIL these and combine like terms. You get this in the blue in the middle. Now we distribute the 4 just like we did on the problem before. And the very last step is we combine these last two terms, the 4 and the 9, and that gives us our final answer here. On this one, it's the same thing. I used the same color scheme. The squared, I rewrote it, so it was 2 of them. And then I FOILed. Again, I kind of skipped a step in here because you have to FOIL it out, then combine like terms. So I get this thing in blue. Next, I distribute the -3, and then I combine the last two terms to get my final answer. This is useful for a lot of reasons. Again, sometimes we want the answers, equations to look differently. I'm going to give these equations a makeover if you want to think of it that way. They're just kind of transforming the equations between how they look different ways. So, yeah, so that's it.